Hello, in this video we will talk about power analysis for one-way ANOVA with R. So first we will talk about power analysis. In the previous video we know that the power analysis lets you determine the sample size required to detect an effect of a given size with a given degrees of confidence. So if you look at this figure, there are 4 items in the power analysis. The first one is sample size. So for balanced analysis, for example, t-test or ANOVA, this means the sample size for each group. And this is effect size. So this item is discipline specific. For example, the t-tests and ANOVA have different functions, calculations for the effect size. And significance level, this means the type 1 error. So we have for example 0.05 significance level. So which means if we reject the null hypothesis in a test, we will make an error as large as 0.05. So we hope this item will be small enough, right? And this is the power. Power is 1 minus the type 2 error. So what is type 2 error? Type 2 error is if the effect is significant, or if we have to reject but we did not reject. So we failed to reject a significant test. So this is the type 2 error. So 1 minus type 2 error, which means the power of the test. So which means if the effect is significant and we can reject it, we can find this effect. So this is the power. So we hope this one is as large as possible. So these 4 items are connected with each other, and if we know 3 of them, then we can find the 4th. So in the power analysis, for example, these 2 decided, and if we also know the power we want to get, so we can find the sample size. And for example, these 3 we know, so we can know the power of the tests, of course. So in ANOVA, the simplest test for the one-way ANOVA is for the 1 factor of different values, different tutor groups for the 1 factor. And we can use this function in R, so pwr.anova.test. Power is a package we have to install first. Then K is the group size. For example, there are 3 treatment groups, and N in the balanced size is for group sample size, and F is the effect size. So for the ANOVA, there are calculation for the effect size. And here is the group's mean value minus the grand mean value, then multiplied with the proportion of this group sample size. Then sigma, then divided by the within group variance, and we assume the variance is same for each group. Then significance level, for example 0.05, and the power, for example 0.8, 0.9. So next we take a look at an example for one-way ANOVA comparing 5 groups. So here the K is 5. Then calculate the sample size needed in each group to obtain a power of 0.8. So the power is 0.8 here, and when the effect size is 0.25, and the significance level of 0.05 is employed. So here we know everything in the figure in the previous page except the sample size. So we can calculate the sample size using this function. So first we have to load this power package. Then we use power ANOVA test K equals 5 and F equals 0.25, and significance level is 0.05, and the power is 0.8. So this is the result of running this function. And here can find n is 39. So which means we need each group at least 39 observations. So there are total about 200 for 5 groups samples. And the result, which means we at least need 39 observations in each group for ANOVA, one-way ANOVA test with 5 groups and with the effect size 0.05. So under these conditions, and we have at least 39 observations, then if we want to make a significance level at 0.05, then we have the 0.8 chance of finding that this effect size is significant, right? So 0.2 chance, 20% of the chance that we cannot reject this size of effect, even it exists. So this is the meaning of the power analysis. And at the same time, when we conclude that the effect is significant, then as large as 0.05 probability, we make a wrong rejection. We make a wrong significant test, right? So this is the significance level 0.05. Thanks for watching.